Hello everyone, and in this video we're going to be taking a look at some things to consider while creating organic topology. We really want to make sure that at the end of the day we don't only have something that looks good but also functions well and is production friendly. So I've narrowed it down to about 4 things to keep track of as you're working, and we're going to use this guy as an example, and I've created some things over here, some extra layers so we can do a comparison with. And there's really no specific order to these 4 things, but let's just go ahead and get started looking at them. And the first one I want to look at here is geometry. Okay, so when you're creating a mesh, you really want good geometry. Now, this isn't looking at edge flow yet or anything like that. These are the basic core things of geometry. And some things you can look for are normals, keeping track of your normals. Are they reversed? Are we creating non-manifold normal geometry? Then we can look at n-gons, triangles, so junctions or things of that nature, things that could cause problems when we go to deform the model, non-merged verts, double extrudes or faces on faces, all those standard type topology issues that could cause problems down the road in our production. So I've created a couple on this model just to show you, and sometimes, the model looks okay and might sit nicely, but you always have to think about what is it going to be doing later on in the production. So I want to take a look at things like an n-gon. Right here you'll see an n-gon created by this little T-junction coming in. Is there a way we can fix this? Is there anything we can do to it? Maybe carry an edge through, but it's an n-gon. N-gons are, as we know, things that are irregular math-wise, they're having the non-four-sided face, they're harder to anticipate what they're going to do, so on and so forth. And same goes true for a triangle. Now, a triangle is the most legal form of a polygon, but when we're trying to stretch and deform a surface, sometimes if placed incorrectly, might not give us the best result. Now, a lot of your triangles will give you heavier star junctions if you have a triangle in an area. So, heavy star junctions or poles, these are another thing. Every time we add an extra edge to a vert, that vert gets stronger in comparison to the other verts around it. So if it goes anywhere in the wrong direction, it can cause a problem because it is stronger than the other verts around it. Okay, so we would definitely want to keep track of those. Okay, they're unavoidable, but if we can keep track of them and minimize the damage they cause to a surface, we want to do that. Again, here you can see, in a highly deformable area, we don't want a giant star junction with a heavy vert. Okay, that's going to cause a lot of problems. And again, you can see that we've got these triangles sitting next to it. Okay, a couple other things, and these are things you may not be able to see when you're just looking at the model. So we do want to look at it in 3 mode. Okay, so we go to 3 mode, and you'll notice a couple things. One, when we get some creasing where we don't want it. All right, so this would be a discrepancy caused by unmerged verts. Okay, definitely something to keep track of. We want to make sure all our verts are merged because this surface right here can actually be pulled apart. All right, that would create a hole. We definitely don't want that. Back here on the ear, we get that nice sharp crease where we shouldn't have it. This is a result of non-manifold geometry, which is caused by the normals being reversed. Very easy fix, but again, it's something we want to watch out for. When you pass on your model to another part of the production, you don't want to be caught up or causing an error somewhere down the line. Okay, so that's geometry. Just go through your meshes and look. Make sure that you have good, clean geometry overall. Okay. Next thing we're going to look at, of course, is shape. Now, I've made some pretty obvious shaping errors, but we're going to talk about this, a little bit differently. But again, I will go to the obvious stuff here. So shape in general, you always have to look at it. Are you getting the shape you're looking for? Okay. It's about the look. It's about what you're creating. You're replicating something for somebody. You're creating your own artwork. You want it to look the way it does. You want it to look correct. You want it to be accurate. This is very important. But not only do you want it to be accurate, and you can see here the skull shape is hurting pretty bad. Over here we've got a better skull shape. I'm going to go ahead and get rid of some of these. All right, so we've got a better skull shape. Over here we're getting a little boxy. So, just looking at shape, always evaluating, doing side-by-side critiques from your mesh to your reference. But another more important thing is, again, remembering where this is going to go in production It's going to go down the pipeline. Okay, it's probably going to be rigged. It's probably going to be posed. It's going to be animated. You know, these are things that we need to keep track of. So you'll notice here that we'll just do a comparison on the geometries. And let me take this one and hit 3. One is definitely more dense than the other one. Okay, and they have pretty much the same shape, so why wouldn't I want to go with this less dense, what we might think is more efficient? Well, we want to look at it not just in 3. A lot of modelers get themselves in trouble by looking just at the 3 mode. Okay, so here 3, here 3, we're achieving the same shape but with less geometry, right? So we don't always want to look at 3. 3 is not what gets rigged. 3 is not what we send to our setup department. We want to look at these models in 1 mode, okay? And you'll notice that this one over here, when we go from 3 to 1, we see a little bit of tightening up on the shape, but we're not seeing a large change in shape. But this one over here that doesn't have a lot of geometry, we see a big change in the nose area, and even more so in the nostril. The more dramatic your shaping becomes in 1, the more shrinkage you're going to see when you actually hit the 3 key. So let's really zoom in on that and take a better look at what's really going on there. We hit the 1 key, see how much we have to pull that geometry to even achieve the nice shape we are getting over here in 3 mode. Okay, this is dangerous because this pretty much says that this is only good for this specific pose. We would have to pull it even more to get it to look the way we want to if we're going to change the position or the pose, if we're going to animate the face, you know, talking, doing lip sync, anything like that, going through emotion. This is going to be, you know, definitely something to keep track of. Always look at your geometry, not only in 3 mode, but in 1 as well. We want it to look good in both 1 and 3. This will ensure that you get better deformations down the line when you hand this off. So again, shape is one of those things we want to look for. Not just are we achieving the right shape, but are we getting good shape in both level 1 or 1 mode and 3 mode. Okay, so again, look at this one, 1 and 3, not a lot of change. This one over here, obviously in the area that I took some geometry out, we are seeing a lot of change. So shape, very important, 1 and 3, very important that both of those still are strong looking assets. Okay, the next one here is going to be density and parameterization. Now these are kind of 2 things, but we want to wrap them up into 1 category. So density is the overall like resolution of your model, density of your polygons. You notice how this one has a very even resolution throughout. Yes, it does tighten up in certain areas, but if there's a reason for it, it becomes acceptable. And as long as we don't see an aggressive change between the levels of density, we should be okay. Now, parameterization, this is about your spacing. We could have an even density throughout a model, but have bad spacing. So parameterization, the spacing of our model, becomes very important as well. This gets into all kinds of things like if we don't have enough geometry in an area, we can't shape that area as nicely as maybe another area that has more geometry or better spacing. So you'll notice over here that this model has poor parameterization and spacing. Here we've got, you know, these rectangular shapes, and we bunch up a bunch of edges, and then we start getting a little erratic, sporadic here in the back. The cheek, we're missing a whole shape there. You know, and right next to it, we're looking at something here that's not too bad. But then when we get over here, our spacing changes, right? So in the same density area, we get nothing. There's nothing there. So this would be incorrect. This would be a little bit more on the correct side. Okay. Now, again, what this really does is it causes or it affects our ability to create shapes in certain areas, or it also creates shaping discrepancies. Like when I go into 3 mode, you'll see these creases and these bands, because we're essentially, with bad spacing, we might be bunching up edges and creating holding edges, which is going to hold a shape or hold a crease where we don't want it. So right there, you can definitely tell when I go into 1 mode, there's going to be bunching there. When I hit 3, I could still see it, and when I click off of it, we get that crease. So seeing the same thing. Okay, so let's take a look at them both side by side again. We'll go back into 1, and you'll see even density parameterization, and it's not perfect, but we see this nice gradient change between the zones where we need more geometry, where we need less geometry. But this one over here, very sporadic, just kind of banding running down the center, creasing happening because of these tightened up edge loops, okay? Uneven density and parameterization. Just not going to be good for future poses, deformation, or a pipeline, okay? So remember, we want to check our density and parameterization. We want to shoot more for this, not for this, okay? Let's move on to the next one here. The next one we're going to look at is edge flow. Now, edge flow is a big one, okay, especially with organics. We really want to make sure that our edges are flowing nicely through a surface. You'll see this one over here. We've got some things going on. I'll zoom in on it. Let me hide the mustache and all this other stuff so we can really look at it. We've got the geometry going in the directions we would need to pull the mouth and create shapes. We've got geometry going over the nostril there so we can get that nice laugh line. We've got geometry sweeping out of the side of the head or of the eye there to create the crow's feet. We also have nice flowing. You see how smooth all of these edges are transitioning through the surface. Okay, this is good edge flow. Okay, now let's take a look at some things that are not so good for your edge flow. Okay, and this gets into erratic. Okay, we really don't want this messy type geometry. And there's a lot of reasons that this gets created, okay? But, and I've made this one pretty extreme just to show you, but I just want to look at a couple areas. Let me zoom in over on this side. This might be better to look at side by side. You'll notice nice and smooth, where this one jets out and then up and then down and then back, right? And it's even getting a little jumbled along the way. This almost guaranteed isn't going to give us nice shape in 3 mode. And when we go to deform, it's just not going to act the way we want. Okay, so definitely one with edge flow. Do you have edge loops? Are they working with the model? Are they where you need deformation? Okay, are you creating a nice edge looped model that's going to be production friendly? And then also looking at edge flow, are your edges nice and smooth, working through your model, not look like a heartbeat? Okay, we always want, especially on organics, we want this nice clean edge loops, edge looping, edge flow throughout our model. We don't want flat spots. Okay, flat spots are basically where you see 3 points and one of those points isn't doing anything. It's just flat. There's nothing happening. You can see it here, very flat, very flat, very flat. In an organic model, we want everything to be moving, everything to be flowing. We don't want that heartbeat again. Things like that. These are just bad things for topology. Another thing is that we start to see this geometry as it's becoming more erratic. When it becomes erratic, we lose our good parameterization, our good spacing. Our quads begin to what we call kite, and when they kite, they look like a kite. Now, sometimes this is intentional, but for the most part, we don't want to be adding stress to our geometry. Now, you can see here by the ear, very stressed topology. There's just no need for that. This is just kind of a mess. It just feels very erratic. Definitely would want to clean this up. And I'll show you how easy it is as we go through. And, it's just a couple little adjustments can really help a model feel nicer and look nicer. Remember, as a modeler, I'm going to show people my wireframes. And when I show them my wireframes, I want my wireframes to look nice. I want them to have, a good feel and be pleasant to the eye. Imagine if these were animation curves. What kind of animation arcs would we be getting? They'd be very erratic and jumbled. Probably wouldn't be a nice smooth animation at all. So we want to do the same thing with our geometry. Just keep it clean, smooth, flowing. It's going to deliver a better shape 100% of the time. Okay, so even that, just a little bit of adjustment looks a lot better than what we had. Okay, so definitely edge flow, very important, not only about your edge looping, but looking at how your edges are flowing through your model and working with the shape. A nice model the edge loops and the edge flow, it's going to feel like the model's wearing the wireframe. Right? I said that before. I say it all the time to people. Your wireframe should look like the subject is wearing it, okay, not fighting it. All right, so these things put together will help you create a model that is aesthetically pleasing, pipeline friendly, usable. You know, it's just a good way to go. So, you know, when you're creating your wireframes, please take these things into consideration. Write them down on a napkin next to you. Make sure you can check them. You know, use them as a checklist. If you can answer all those things and say, you know what, I've got good edge flow, I've got good density and parameterization, I've got good shape, both of 1 and 3, and I've got good geometry, good polygons overall, then you can pretty much be well assured that your model is going to be pipeline friendly and ready to go. Okay, so enjoy, use that information, and can't wait to see what you turn out.